task in Shiny.
Thank you, Julianne. So yes, I'm here to talk about asynchronous processing of long-running tasks in Shiny. So we'll start with a little background. So we all seen how great Shiny can impact our workflows and improve them. But when we have really computationally intensive tasks, Shiny is not necessarily the most ideal solution. And in particular, relying on an active browser session for long-running tasks is unreliable. We've been there where we're using a Shiny app. Maybe you disconnect from the internet or the Shiny app quits down, and now you've been running something for 20 minutes and you have to restart. And also processing time for these long-running tasks is really dependent on the device performing the task. So if you have a slow processor, your task might take exponentially longer. With our proposed solution, we'd address these problems. One, by deploying a Plumber API to perform these long-running computationally intensive tasks. We'll utilize the httr package to route requests to Shiny app, and we'll utilize the pins package to store the status and the results of the calculation. If you're unfamiliar with either package, I'll drop a link in the chat after so you guys can get more familiar with these two packages. And then lastly, we're hoping to host this Plumber API on a server with a heavy-duty processor to really help reduce these processing times. So when we sought to create our API, we had to first think about, okay, how do we actually send these inputs to the API? So on the server side of the Shiny app, we create this list called outlist, and that's what's going to end up being sent to the API. The list contained 4 different items. One, our list of function parameters. Next, our input data set that's going to be used for the calculations. We generate a unique ID for each of the calculations, so that's this ID. And then lastly, we use it in the username. I know myself, I tend to lose numbers, and IDs. So if you forget your ID for your calculation, you can also look up what you submitted by your own username. Then we had to convert that list into JSON format. Plumber APIs need JSON format data in order to process them. So you just use the JSON-like package to do that. And then lastly, this is where the httr package came into play, where we actually were able to communicate with the API. And as you see in the green text, you put your URL for where you're hosting the API, and then followed by the with a / with the endpoint of that you actually want to route this request for or to, and then the body is just that JSON object that we created. So once we got the data to the API, then we had to look at how the API would actually route these requests and process them. So when a request is received, a pins board is created using the pins package to track the status. And a board is basically just like a place to store the actual information. The calculations are then initiated. So these two actions kind of happen simultaneously. Within the Plumber API, we're utilizing the promises package, and in particular, this newly developed function called future promise to allow us to handle multiple requests. Now, once the calculations are finished, the calculation status pin board is updated from calculating to finished. Then the results in the calculation are posted to a new pin board specifically for the results. One nice feature about pins is that it's really accessible and a really easy way to share data. So these results can be retrieved either using the original app directly, creating a separate app to track anything going on your pin board, creating an API endpoint so you can route your request through your API, or even just write a simple R script to grab the data from this pin. So here we're going to give a nice little overview of what the workflows could look like. There's 3 we're going to cover. So first, we'll talk about initiating calculations. The app user is going to submit data and the parameters to the Shiny app. The Shiny app is then going to route that task to the API. Then the API is going to run the promises workflow, save the task status, and then eventually when the task is finished, save the results. So that's our first workflow. So the second workflow, I've submitted my calculations, I've walked away from my computer, come back, and I want to check the status. So the user is going to check status using the Shiny app. The Shiny app, we opted to actually bypass the Plumber API here. The Plumber API is going to be hosting a lot of really difficult computations. So if we can limit what we route through there, the better, the more it can focus on calculating the computations. So we're going to actually go straight to the pins board, grab that status and get that status of running, and then it's going to display that the calculations are not quite ready yet. And finally, your calculations are ready and you want to actually retrieve your results. So pretty similar workflow in terms of checking status. We're going to check the status. We're going to, again, bypass the Plumber API and go straight to our pins board. We're going to get this notification of finished, and then the Shiny app is going to then go retrieve the results from the results pin board. And then those results will either be displayed or allowed to download for the users. So now we'll talk about the specific use case that inspired this creation of the Plumber API. So here we have the Bayesian model averaging for dose finding studies, or BMA mod for short. A little background on that. As we know, finding the correct dose for relationship is vital for drug development. And with conventional dose response analyses, conventional dose response analyses consider the functional form of the dose response relationship, but we may never know if that's the correct or the true or what the functional form is. So this kind of limits the abilities of these traditional analyses. With this method, we use an estimation-focused Bayesian approach to carry out the calculation without ever assuming the functional form. So on the right, you'll see this long function call. That's this mcmc menu.fn is our parent function call that triggers all the downstream effects. And that list that we created with the parameters, this is what it gets fed into. So now we're going to actually take a look at it live in action. So here we have our BMA mod app, and I'm going to go ahead and play the demo. So we'll open up our app. And then we're going to click Start BMA Mod to start our calculations. And then we're going to go ahead and click Confirm to load our data into the environment. Our response variable is X. We're going to choose a continuous response type, and our dose variable is dose. We're just going to pick a linear model, just one type to feed into the simulation. And then we generate a unique ID. Again, if you lose that ID, no worries. There's another way for you to look it up, but where you can save that ID. Next, we're going to navigate to our calculation status. So realistically, you can shut the app down and do this without the app being open. Reopen the app and run this, but I didn't for this example. And then you'll see there's also two options by calculation or user ID. Here, I'm going to paste in that calculation I copied, and we'll get the results. That calculation is still processing. Yesterday, I used this app and I submitted a different calculation, and I want to check, is this done yet? So we're going to go ahead and enter a different calculation ID of something I submitted the previous day, and we're going to check that status, and we're going to get our calculation is done. We'll download our results, and here we go. You can see here at the top, they're downloading. I've even looked at my results from another example. And then finally, like I said, sometimes you forget a calculation ID. There's a ID, so you can go ahead and enter your user ID here, and then hit search, and there we go. And you can see your calculations grouped by whether they're finished or not finished. And our final slide here as we wrap up. So some considerations and limitations. A few helpful notes. Utilizing access type within the pin write function helps whenever you're posting a pin to the RStudio Connect. And so this access type parameter, as we know with RStudio Connect, objects that are deployed, you can limit, like if it's just a specific user, anyone logged in or no login required, so you can use that parameter to filter that requirement. This method also works for anything that was written into the global environment. I have our use case wrote objects to the global environment, and we first thought maybe we should change it so that it returns the value, but you can work with things that get written to the global environment. And some mention on limitations quickly. When using pins that are deployed to RStudio Connect, it uses the account of the user deployed who deployed the API. So the full name of the pin is the user ID / the pin name that you gave. You can access it without the user ID, but if two users deploy the same name pin, you might run into a problem. Sourcing R scripts can be a little tricky. When we tried to source our full R script, some of the functions weren't found. I don't know if it's because of how we set up our function or because of how plumber works, but if we pasted the whole script into the top of the plumber, it worked. So that's just one thing to mention. And one final thing, the future promise is an experimental function. So future promise is the future and promise separate function workflow can be used, but there are limitations. I'll put that link in the chat as well so you guys can read a little bit more about that. And with that, I'll say thank you.